Hello again. Look, I want to consider an example here, and once again we're going to be focusing on using Kirchhoff's laws and also Ohm's law. And let's see if we can come up with the relevant equations to solve everything in this circuit. That's the currents in the branches, the voltages across the resistors, and so on. All right, so here's our problem. Now we're not going to come to a complete solution here. What we're going to do is basically write down the relevant equations. Okay, so what do we do first? Well, we need to define our currents, okay? Now these are arbitrary choices, so let's do that. So let's say we've got a current here. Let's call this current I1. We've got a current in this section here. Let's call that current I2. We've got a current here. Well, we can call that current, let's say I3. Now we can talk about a current in here. So let's go ahead and call that I4. And of course we've got a current in here. Well, we could go ahead and call that guy I5. And then we could talk about a current flowing here, and we could call this current I6. All right, so really there are 6 currents that we are actually dealing with. All right. How many nodes in this circuit do we need to worry about? Well, there are several nodes. I mean, we've got a node sitting over here, we've got a node sitting over here, a node sitting here, a node sitting here, okay? How many loops are we worrying about? Well, we've got a loop, and a loop. All right, so let's start writing some stuff down. All right, so here's our first loop. We'll call this loop number 1. Let's write down a loop equation here, okay? So loop number 1. Now, before I do that though, let's label the voltages to be consistent really with these defined current directions. So if this current is flowing this way, I've got a plus minus, right? This current is flowing down, so it is plus minus. This current's going this way, so that's a plus minus. Let's see what else. This current's going this way, so that's plus minus. This current's going this way, so that again is plus minus. This current is going this way, so that's plus minus. This current's coming on round, going this way, and so we can talk about a plus to a minus. So current going this way, like so. All right, so that's the circuit that we're really dealing with. All right, loop number 1, we're summing the voltages. Let's start here. So if we go up in voltage, we call it what? We call it positive. So we've got 5 volts. We're dropping plus to minus, so we're going to say it's a minus I1 times what? 1K. Coming on round, well, we're going from plus to minus, we're dropping again, so that's a minus what? I3 times 500. Our voltage source sitting here, so we're going from what? A minus to a plus, so that is what? A plus 10. Coming on round this way, we're going from a minus to a plus, minus to a plus. We're going up in voltage again, so that's what? A plus I4 times 4K, and we're back to the beginning, so all of that is equal to 0. All right, so that is loop number 1. All right, let's call this guy over here loop number 2. All right, loop 2. We'll write down our loop equation for this. So where do we want to start? Well, you know, we went clockwise around that loop. We could do the same here, or we could go the other way, all right? So let's go the other way, okay? That way there. Am I missing something here? Yes, I am. That's I2, isn't it? So I2 is what? Flowing in this direction. That's the way I've defined it to be flowing, in this direction. And so that would be what? A plus and a minus sitting there. I haven't put the value of that resistor there, so let's just make up a value here. Let's say it's 200 ohms, okay? So here we go. We're starting right here, we're going to go up. So going around in this direction. So we're going from plus to a minus, which means we're falling. That's the I2 current flowing there. So we're falling, and so that's a what? A minus. That is an I2 times 200, isn't it? Yep. Then we go what? From a minus to a plus, so that is a plus 20. Coming on round, that is a plus to a minus. Again, it's falling, isn't it? So that's a minus I2 times that 2k. Coming on round, we're again falling. That's a plus to a minus. So that's a minus what? I3 times 500. We've come to our source here, so that's a minus to a plus. What is that? That is going up, so that's a plus 10. And then coming on round, we're going from a minus to a plus. That is I5, isn't it? So that is a plus I5 times that 5k. And we're now finally at the beginning again. So all of that is equal to 0. All right, that's that loop. Well, let's have a look at loop number 3. Okay, so loop 3. All right, where do we want to start? Well, it doesn't matter. Let's start here. We'll go around clockwise. Okay, so we're starting here. Now, this is I6, isn't it? That's what we defined as I6, wasn't it? Flowing in this direction like this, okay? All right, so we're going what? Down. We're dropping from a plus to a minus. So that would be what? A minus. We're talking about I6, aren't we? Times 400. All right, we hit the next component. That's a plus to a minus. We're dropping again. So that's a minus, what? I4. And that's times 4k, isn't it? Okay, continuing on round, we're going from a minus to a plus, which means we're going up. So that's really a plus I5, isn't it? Times, what, 5k. Coming on round, we're dropping again, so that's a plus to a minus, isn't it? So it's going from a plus to a minus, and so that's a minus I6 times 1.5k. We're back at the beginning. All of that is equal to 0. All right, so those are the 3 loop equations. We could write down node equations, and we might just do this, okay? So look at this node over here. What's coming in? I1 is coming in. So I1's coming in. What else? I2 is coming in, so that's a plus I2. I3 is going out, so it's a minus I3, and all of that then is equal to 0. So that's one of our node equations. Another node equation could be this one here. Let's just write that down. Okay, so going out, we've got what? I1, so that's a minus I1 because it's going out. Coming into that node, what have we got? We've got an I6 coming in, so that's a plus I6. And then also going out is an I4, so that's a minus I4 is equal to 0. Okay, let's look at this node over here, and we'll see what's happening there. Well, I2 is going out, so that's a minus I2 going out. I5 is going out, isn't it? So it's a minus I5. And then I6 is also going out, so it's a minus I6. And all of that is equal to 0. All right. Well, we could talk about this node over here as well if we wanted to. And we could say, let's just write that down. What's coming in? I4 is coming in, so we'll write that down. I4 is coming in. I5 is coming in, so that's I5. And then, of course, what do we have coming in this? Well, that's actually coming in, isn't it? In this direction, that's the defined direction. And so that's a plus I3, and all of that is equal to 0. All right, yes, it's a complicated problem to solve. You know, the mathematics of solving basically for all the unknowns, well, look, that's involved. And we don't want to do that. What I wanted to do here was demonstrate the actual circuit analysis part of this, which is actually using Kirchhoff's laws and Ohm's laws to actually write down the equations that really need to be solved. So you can see once we get the hang of writing down loop equations and node equations, even a complicated problem such as this, it's really relatively easy to get the required equations. Mathematics is harder, yes, a lot to solve, but as I say, let's not worry about that. Let's just focus on the circuit analysis part of this, which is getting these basic equations. All right, so I hope that helps you. And once again, I'll see you next time.